Today, we will be taking a look at Cursor Agent Designer, which can design complex LLM-based agentic systems. It can also design very complex agentic systems, as you can see, with parallel processing and sequential processing of LLM API calls. All you really need is a cursor rules file, which we will talk about, and then a system design file. This is where you specify your system. You can, each line here represents a sequential process, plus you can enter in a single line parallel processes. I have two versions of this, a basic one and an advanced version where we can actually use four different models such as OpenAI API calls, Anthropic API calls, Perplexity, and OpenRouter. So this advanced version will be available at my Patreon, but we will actually talk about the basic version, which you can actually build upon. The ideas are exactly the same. Link to both the free version and the advanced version will be in the comment and the description. So let's first see how this works. As long as you have your .cursor rules file and then your agent design, you can just ask Cursor Composer in agent mode just to begin or implement the process. Okay, I'm making sure that I don't put any context because it's supposed to read the context itself. Okay, it's going to help us. It first searches for the agent design.txt file. It reads it because that's where our specifications is. And then it makes a plan, and then it starts creating the flow.md for the flow chart. Let's see how it creates. It's going to override this. Okay, our new flow chart has been created. Here we go. We're going to take in user input, generate a response, write that to file. Then we're going to generate a summary, bullet points, and a main takeaway, write these to file, and then we're going to be able to repeat this by passing in the output back into the LLM. So that's how we designed it in the agent design.txt. Now it is creating the actual agent code, and that has been created right here. We accepted. This is the code along with our parallel processing, which will execute with asyncio.gather. So everything is done for us now. And we can actually run this as well. So we can specify enter a number of interactions. Let's just say one, and we need to enter a user input. Let's just say what is matter, and we are making a call to GPT-4o just to get an answer, and then we make three other calls. Here was the original response, as you can see, and we have also generated a summary, the bullet points, and key takeaway from the original call, and all written it all into the response.txt file. But the important part here is that our agent was designed just from this agent design.txt. As you can see, we will take a look at the cursor rules file, but the way it works is the cursor is instructed to take every new line as a sequential process. Here we are telling it to take user input, then generate a response. It knows that it should use GPT-4o for this. Write this to file. And the interesting part is line number 6, where we say summarize response plus bullet point of response plus single sentence takeaway, and then write all these to file. So this line will be interpreted as parallel processes, concurrent processes, and will execute with asyncio.gather, and then we say repeat with new responses for m many times. So essentially, with the simple instructions, you can get Cursor to generate complex LLM-based agentic systems where you can write sequential processes, parallel processes, and loop-like structures very simply in agent design.txt. And all of this is facilitated by the cursor rules file. Now, again, like I said, we will be going over the basic version, but the more advanced version, which can use multiple models along with structured outputs, is also available and is available at my Patreon at architect level. So let's take a look at cursor rules file. This is where we instruct Cursor to actually build, take this agent design.txt into account and build our agentic system. We are asking it to be a LLM-based agent systems designer. You will use only this type of API call, and we just give it a regular text completion because we want to keep things tight and easy. There's a lot of edge cases may pop up, but I tried to deal with that in the more advanced and try to actually build a system which builds using multiple API calls and structured outputs. Anyway, we give the API call example, and then we ask it to check agentdesign.txt for specifications and build it. Always create a generic module LLM function, which you can reuse for different tasks, because this is, if you were to wrap this in an async function, we can reuse it for different tasks. So we are trying to encourage model to do that. If tasks are explained in new lines, that means sequential processing, one after another, such as take user input, generate response, write to file. So these are new lines, each on their own. You can have as many as you like. If the user uses plus sign in the same line between tasks, that means parallel processing using async IO for those tasks. Plus sign always separates multiple parallel tasks. This is very important to understand and remember. So this is the trick to get it to execute to write concurrent processes, such as we give an example: summary of doc 1, summary of doc 2, summary of doc 3, analysis, etc. Important part is that so they're all in a single line, very simply defined, with plus separating them. Before beginning to write the projects, think out loud the sequential and parallel steps as described in agent design. Agentdesign.txt. Paying attention to plus sign, separating parallel tasks. We reiterate our instruction. Write the agent code in agent.py file. And here we are asking it to write a flow chart in an HTML file. And also we are asking it to write a mermaid chart. But you can also use these statements, ignore, colon, in the cursor rules file, just in case if you didn't want to have a bunch of cursor rules file and want to ignore some of your rules, you can actually use this. Essentially, it's going to write a mermaid chart. We are ignoring the HTML. And here we are defining general rules for it to use term color printing for colorful printing, to use UTF-8 encoding when we are writing and reading the files, always to use try except blocks with descriptive printing, including the error itself. This is going to allow us to debug if any errors arise. Let's implement every project with separations of concerns in mind so that we have different functions for different tasks. Create and update requirements.txt without version numbers, because it only knows the version numbers of old libraries. That's why we're asking it to do that. Always make sure to await all async tasks, because this is important. It can have a tendency to forget that. We do need to await for calls such as chat completion. Always create a generic and modular async LLM call function which you can reuse for different tasks and models. Make sure all async calls are awaited in their respective functions. And here we define the action steps, finally reiterating for it to first to read the agentdesign.txt file and understand the tasks. Make a detailed plan for the tasks, including details such as model names. This is the planning part. And then write the flow chart first, because this way we can actually observe the flow chart and see if it's not going well, we can maybe cancel the request. And then write the code to agent.py file, and finally perform a review diagnosis step at the end. Make sure that everything checks out. So it sometimes skips this step, but as you can see, it has performed the checks right here. It thinks that everything was implemented correctly. And since we have already run this and seen ourselves that it actually worked well. So the more advanced version deals with quite a lot of edge cases. It took me quite a long time to actually get it working fine. You can download it by becoming an Architect patron. The link will be in the description. And the more advanced version can actually create quite the complex structures, such as taking user input. We generate 3 alternate search queries, and then perform perplexity search in parallel for all, write these to file, and then we get a summary by Gemini Flash model, bullet points by Claude, takeaway by Flash model, and entity extraction using OpenAI, and write the analysis to file. So I hope you found this interesting. I think this is quite powerful, and I'll see you in the next video.
Now, listen to me. I've been trying to code, and like I like coding, the fact that I can code and make things happen. But how do I do it? I mean, fast with AI. I heard about it. It's easy. So I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one on one. Check those out as well.